I welcome all of you to this video where we are increasing things slightly by means of complexity in terms of double integrals and area between curve applications. I am Mr. Ish. Thank you for joining me. Very recently I presented a video where we were looking at double integrals in terms of area between curve determinations, except in that particular case we were looking at parallel sided polygons where you were integrating an interval across another interval, but everything was parallel. As you see, you're going parallel up, you're going parallel across. In this video we're going to increase that in terms of complexity when we do not look at something which is parallel. Consider this representation here, a point B, 0, 0, H. Connect them by means of a segment and you've generated a triangle. This point right here is 0, 0. And if I want to integrate this interval limits or this definite integral across another interval and set of limits, another definite integral, look what happens. If I'm taking it straight up, I can't, because then I'm looking at nothing other than a rectangle or a square. When I have a triangle here, my left finger will keep going straight up, but my right finger must trace the curve, and I'm seeing convergence over here. That convergence is a problem because I've lost that parallelism which I had in the previous video. If I want to take this interval and do it across, I can take my right hand across and there's no problem, but the left hand must converge and it must follow that segment. That right there is our problem. This convergence creates a problem. It's a unilateral convergence only on one side. On the other side we don't have convergence or divergence, but that single-sided convergence and or divergence, if that were the case, creates a problem. How do you deal with this problem? Well, you must account for the fact that if you're going upwards, you have to trace the curve and converge. And I'm going to show you how you do that. If I want to determine the area of this region, I don't want to use my traditional means, which you know, AB yt minus yb dx, or c to d vertical limits xr minus xl dy. I don't want to do that. I want to do my new double integral way, and I'll show you how you do it. You're going to be essentially integrating this limit and we will integrate it upwards. Since I'm integrating upwards, I'm going to be tracing a line. I must now need an equation of a line. In the previous video we didn't need equations. We were simply taking the limits and integrating them across, but that's the ease which comes with parallel sided polygons. We don't have that. You must determine this equation. Y is equal to minus h over bx plus h. That's the equation of this segment right here. If I'm tracing upwards, I must convert this equation into x equals, and I will. X is equal to y minus h times minus b over h, or I can say x is equal to b over h times h minus y. I've gotten rid of this minus, but I've flipped these around. Again, look what I'm doing. I want to take this interval between these two limits and I want to integrate upwards, but I can't. I have convergence here, therefore I must follow a certain segment to meet and comply with that convergence, and that segment equation must be determined. Since I'm going upwards, I'm doing x equals. If I was going in this direction and I must trace down, then I would have a y equals line. Now look, this is what I'm focusing on, integrating upwards. My integral will be this. With respect to dx, I was 0. But see right here, b comma 0 is kind of x comma y. You must bring this equation into your limits, because again, we're not integrating functions, we're integrating limits, intervals. You must convert this into a limit. How can you do it? Well, I have an x comma y. I have here an x comma y, b over h, h minus y comma 0. I've converted this into this and I've brought the equation into a limit. When y is equal to 0, h minus y is h minus 0, which is an h. H will hit with this h. You'll end up having b comma 0. So this limit, upper limit, is perfect. It's b over h times h minus y, and that's my upper limit. It's no longer b. I've brought the equation into my upper limit, and that will give me everything I need. This now will integrate upwards from a 0 up to h with respect to dy, and that's my double integral. That'll give me the area I need. Solve this. You'll have an x come out of it from b over h, h minus y, down to 0. You can open this up. You'll have a b over h times h, which is a b, upper limit b minus by over h. And see it, I've just opened it. B over h times h is a b over h times minus y is that. Upper limit, lower limit, the difference of the two, all you'll get is a b minus by over h. That's coming out from right here. But this is no longer a constant, which I'm just going to put right here. There's a variable in here. Now that must integrate with your next integral. Hence, the increased complexity with this. Your next integral is 0 to h with respect to dy, as you're seeing right here, but this is your integrand by over h. The outcome of your previous integral, your inner integral, is serving as your integrand of your next dy. Integrate this by minus by square over 2h with the y as a variable. Simple polynomial integral, h in the 0. You will have a bh minus bh square over 2h, which is bh minus, this cancels out with this, bh over 2, and you simplify that, you'll have a half base times height, which is the area of this. A triangle has the formula half base and height, and I've shown you this by means of double integral approach. Again, remember the complexity of this. No longer parallel sides. You can't just simply take an interval, its limits, and just shoot them up or shoot them across. You have to account for the fact that you have convergence. You do that by means of an equation in the proper format. That equation will make its way into some form of a limit. That limit will now come into your integral, which will then integrate across another set of integral limits. And you see the upper limit here is your equation, x equals format. X equals format, and you know it. This right here was my x equals equation, which became part of the limit. That's all I'm showing you here in this video. In the next video, where I'm showing you the part 3, we will have a more difficult representation to integrate. Have a good day.